times 10 to the power 23. So if you are told to calculate the number of moles of a substance and you're given the number of particles, just know that it is actually the number of particles all over 6.02 times 10 to the power 23. Now let's look at the molar mass of any substance. What is molar mass? Molar mass is simply the mass of 1 mole. Mass of 1 mole of that substance expressed in gram. The oxygen is 32. That's oxygen molecule is 32 grams per mole. Sodium is 23. No, sodium is a single atomic. Well, it has one atomicity of 1. Hydrogen ion is 1 gram per mole. Calcium oxide, which is CaO, is actually 56 grams per mole. 56 because this is 40. Mass of calcium is 40 and that of oxygen, single oxygen is 16. So you have 40 plus 16, 56. So very, very importantly, this one is for oxygen molecule, O2, which is 16 times 2 to give us 32 grams per mole. So very, very importantly, you need to know what molar mass is so that you can, when doing calculations, you can easily use it and what 1 mole is, and you need to take note of the Avogadro's number. Thank you. Hello, welcome. Today we're going to be looking at laws of chemical combination. When elements combine, how do they combine? What are the laws that govern their combination? And today we're going to be starting with the law of conservation of mass, which states that matter is neither created nor destroyed during chemical reactions, but can change from one form to the other. So the laws of chemical combination includes laws of conservation of mass, laws of definite proportion, and law of multiple proportions, as well as the law of reciprocal proportion. So we're going to go through these 4 laws. So number 1, the law of conservation of mass states that matter is neither created nor destroyed during chemical one form to another. So in WAEC, in your JAMB or NICO, you're going to see this law stated and you're going to be asked which law is stated. Is it the law of conservation of mass or law of definite proportion or multiple or reciprocal? So whenever it is stated like this, that matter is neither created nor destroyed during chemical reaction but changes from one form to the other, know that it is the law of conservation of mass. Now, the law of definite proportion states that all pure samples of a particular chemical compound contain similar elements combined in the same proportion by mass. That is the law of definite proportion. All pure samples of a particular chemical compound contain similar elements combined in the same proportion by. Now we look at the law of multiple proportion, and the law of multiple proportion states that if 2 elements, A and B, combine to form more than one chemical compound, then the various masses of one element A, which combine separately with the fixed mass of the other element B, are in simple multiple ratio. This is fixed mass, please. There is mass here, I missed out on it. So please take note of these law of multiple. If 2 elements, A and B, combine to form more than one chemical compound, then the various masses of one element A, which combine separately with a fixed mass of the other element B, are in simple multiple ratio. So these are the 3 laws of chemical combination. The last one is what we call the law of reciprocal proportion. So that is the 4th law of chemical composition, of chemical combination. And what does this law state? This law, the law of reciprocal proportion states that the masses of several elements, A, B, and C, the law of reciprocal proportion states that the masses of several elements A, B, and C, which combine separately with a fixed mass of another element D, are the same as or in simple ratio as in the masses in which A, B, and C, the masses of several elements A, B, and C, which with a fixed mass of another element D, are the same as or in simple ratio as the masses A, B, and C combine with one another. And that is the law of reciprocal proportion. So those 4 laws are the laws of chemical combinations. And as a student that is going to write WAEC or JAMB or NICO, you're supposed to know these laws. You're supposed to know how to state them. And you're supposed to know how to pick them out whenever they are stated. And you are told to pick out the option that rightly describes the statement that is made. Thank you. Yes, welcome back. We are going to be learning states of matter. States of what? Matter. States of matter. What do you understand by the term states of matter? The physical states in which the matter exists in. You understand? There are 3 major states of matter. We have the word solid state, the liquid state, and the word gaseous state. So those are the states of matter we have. We have the word solid, we have the word liquid, and we have the word gaseous state. So these are the 3 states of matter. How do we understand it? When we have something like ice, the ice that we get from our fridge, isn't it? The ice block. When the temperature goes up, what do we have? The ice will turn to what? Liquid water, isn't it? Then when the temperature continues to go up, then we have what? Gaseous, which is what? Which is what? Vapor. Which is what? Vapor. Which is what? Vapor. So those are the 3 states that a given matter can find in. What matter is changing from ice to liquid to vapor? What matter? Water, isn't it? Yes. Is it not water? Yes. Which is what? H2O, is it not? Yes, sir. So when it was ice, it is still H2O, isn't it? Yes. When it is liquid, it is still H2O. When it is vapor, it is changing from different states to the what? Order. It is changing from different what? States to the what? Order. And that's what we call it states of what? Matter, the physical state. So this physical state has to be it has something to do with the arrangement of the particles of the water. You understand? At one point, there is very less kinetic energy. Which point has very less kinetic energy? In the solid state, kinetic what? Energy. And what kind of arrangement does it have? It has a closely packed what? Particles. Closely packed. And this one happens at what? Low what? Temperature. So, in the physical state of solid, in the solid state, the particles have what? Low temperature. There is what? Less kinetic what? Energy. And there is what? Closely packed particles. Is that clear? here in liquid state we have there is what we call high temperature, is it? And there is more kinetic energy, is it? And the particles are loose. They are loosely packed. They are a little bit loosely packed than the solid state. But in liquid state we have very high temperature, is it?
Yes, sir.
Very high temperature. Then there is even more kinetic energy than here, is it?
Yes.
More kinetic energy. And the particles here do what? They are scattered. Is that clear? So that's why here we have ice, and here we have liquid, and here we have vapor. Is that clear? Is that clear? So these are the different states of matter, and this is what differentiates them. You understand? What differentiates the different states of matter is what? The temperature. If the temperature is low, you expect that the particles of the solid will have less kinetic energy. And because it has less kinetic energy, it will be more closely packed together. That's why we are having it in solid form. But when you increase the temperature, the particles of the matter acquire more kinetic energy and they will start moving. You understand? And they become loose. So we have what we call liquid state. When you continue to apply more temperature, the particles gain more kinetic energy and they tend to scatter. Then we have what we call the gaseous state. So what are the physical processes? What are the physical cause change of state? That do what? Cause change. Or who can tell me the processes that cause change of state? Number one is what we call what? Number one is what? Melting. Melting causes change of state. Melting will cause the change of state from one state to the other state. From solid to what? Liquid. It is called what? Melting. That's the process. Then which other one? Called what? Evaporation, or vaporization, isn't it? Vaporization. That is from what? Liquid to what? Gaseous. Vaporization. So JAMB is going to draw something like this and write A here, and they will ask you what process causes the change from liquid to gas. What's the answer? Vaporization. What other process? Condensation. What happens in condensation? From gaseous to what? Liquid. We have what? Condensation. What other process happens? This condensation can also be called what? Liquefaction. Liquid what?
Faction.
That's turning of gas into liquid. Liquefaction. That's another word for condensation. Freezing or solidification. That's when it changes from liquid to what? Solid. We have what we call what? Freezing or what? Solidification. So the opposite of melting is what? Freezing. And the opposite of vaporization is what? Condensation. Is that clear? Now what other process of that is a state change of state? Sublimation. We also have what? Sublimation. What is sublimation? When it changes from gaseous state, from what to what? From solid straight to what? Gas, without changing to liquid. When it changes straight from solid to gas, we call it what? Sublimation. So those processes are what? Melting, vaporization, sublimation. We also have what? Freezing. Freezing, or we call it solidification. Then we also have what we call condensation. Condensation, which I have already explained. So we have condensation, freezing, and what? Sublimation. So those processes are processes that bring about what? Change of state. They bring about what? Change of state. Change of state. And you're supposed to know this diagram that shows from solid to what? Liquid, gaseous state. And you're supposed to know what happens in solid state. There is what? Low temperature, less kinetic energy, and closely packed particles. Better or bigger temperature, higher than this, but not as high as in gaseous state. There is more kinetic energy, and there is what? It's loosely packed. The particles are loosely packed. Whereas in or high temperature, not actually very high. But when the temperature is high enough to give it more kinetic energy, in order for the particle to scatter, we have what we call gaseous state. Understand? And this can easily be explained by what? Ice, water. Water can be in form of ice at a very low temperature and less kinetic energy and closely packed state. But when you apply heat, you know that heat increases the temperature. So when you apply heat, the particles will get more kinetic energy and tend to and turn to what? Liquid. Then when you continue to apply heat, like you're boiling your water in the kitchen, what happens? It starts going into what? Vapor. The gaseous state. Is that clear? Yes. So that is the process of change of state. Yes, welcome. We are going to be studying the properties of matter. Properties of matter. Properties of matter. Properties of matter. Matter or substances are identified by their characteristics. Is that clear? You can identify a matter by its characteristics. And these characteristics that you identify matter by are known as the word properties. Is that clear? Any characteristic that you can identify a matter by is known as its what? Its properties. So we can say that matter can be identified by its what? Character. Its character. And these characteristics is different from something. You can always identify that by the character of that thing. You understand? If this is different from this, you understand it. So these properties could be so there are two types of melting points. But this one melts immediately. Maybe at 100 degrees Celsius. But when you hit iron, even at 100, it will not even move. It will just stay like that. So you say, no, this is water, this is iron, because two of them have different characteristics. So melting point is a very important aspect. Melting point at 0 degrees Celsius, water is still ice, isn't it? Yes. But at 100 degrees, it melts towards gaseous state. So you can use melting point. You say, since water melts at 100 degrees. But iron does not melt at 100. So when you test the two of them, you can say this is iron and this is what? Water. Number 2 is what? Boiling point. Number 2 is what? Number 2 is boiling point. Number 3 is what? Density. Density, that's the weight, the mass. You understand? With respect to its volume. Density. Then what other quantity? Solubility is another one. Solubility. You understand? Solubility. That's this ability to dissolve in water. You understand?
Yes, sir.
This ability to dissolve in water or any other solvent. That's solubility. You know, so sometimes they dissolve in water, but they don't dissolve in other solvents. Another, this physical property is what? Color. There are some things that once you see the color, you know that this is the substance, isn't it? Colorless, isn't it?
Yes.
What other characteristics or odor, the smell. There are some substances that have repugnant smell. Once you hear the smell, you just go out. But some don't have smell. Like water does not have smell. You understand? Water. If you get across sulfur, it has bad odor. Or ammonia. You say this is ammonia. This is the smell. Then we'll talk about chemical properties. What are things that we can call chemical properties. Chemical properties. These are changes to form new what? Substances. So when matter change to form new substances, we talk about chemical properties, is it not?
Yes, sir.
And it could be in so many forms. It could be in form of reaction with one other substance, is it not?
Yes.
Good example is rusting, is it not?
Yes.
Iron, they rust in the presence of water and oxygen, isn't it?
Yes.
So other substances undergo different chemical processes, like when they react with water or the oxygen in the air. When they react with any other gas across the environment, they change. Exactly.
Yes, sir.
So, we gain various forms. But very importantly, you need to identify these physical properties. You use them in testing. When you go further in gas, you use things like boiling point, melting point to identify that this is this and this is that. But when you go into advanced chemistry, you also see that you use chemical properties to also identify. When something can react with oxygen, the degree which it reacts with oxygen can tell you that this is a compound. Is that clear? Thank you. Hello, welcome. Changes. Matter undergoes two types of changes. Matter undergoes how many types of changes? Two types of changes. Matter undergoes two types of changes. Number one is what we call the what? Physical change. And number two is what we call the what? Chemical change. These are the two types of change that matter can undergo. And I told you that example of matter is an ice block because it has mass and it occupies what?
Space.
Matter is anything that has mass and occupies what? Space. Common salt. You know what you use in your house to cook, isn't it?
Yes.
That is matter because it has weight and occupies what? Space. So matter like ice block or common salt undergoes two types of what? Change. Iron is, isn't it?
Yes.
Is a matter, isn't it? It undergoes changes too. You understand? So any matter can either undergo a physical change or what? Chemical change. A physical change is a change from one state to the other that is reversible. Example, when ice changes from ice block to water, can it be reversed?
No.
When ice changes from ice block to water, can it be reversed?
Yes.
How can you reverse it? Putting it in the freezer, isn't it?
Yes.
It will get back to ice, isn't it?
Yes. So
it is reversible. So therefore, what kind of change is that? Physical. Whenever there is a change from one state, in ice block, what state is it in? Solid state. It changes to water. Water is in what state? Liquid state. Whenever there is a change in state, we call it a what? Physical change. Because it is what? Reversible. Is that clear?
Yes.
So physical change, what? Absence of air. Heating of sulfur in the absence of